compared to like Python or JavaScript, it is a lot more work to get going. Prime here is discussing another video.
Great. So C++ is pretty great, and you may think it's worthwhile learning. But before jumping into a C++ tutorial, it's worth understanding some of the drawbacks to the language.
Okay, let's go.
The tooling around C++ is nowhere near as wonderful as it is in other languages. In fact, organizing your code project and build tools are probably some of the harder parts of using C++. There's...
Hey kids, you want to learn a language called C++? Well, let me teach you CMake! You're just like, what? What does CMake do? CMake makes make files! You're like, what?
There's very little hand-holding here unless you use an IDE, which I'd probably recommend to somebody new to C++. Setting up your project with configurations and makefiles is going to be way too much just to get started. Lack of dependency management available to you. Instead, relying on system libraries instead of what other languages provide, such as npm for Node.js or pip with Python. If you really want to learn as much as you can about software development, then C++ can help you get there. But if you just want to build something as quick as possible, then C++ is probably not the right choice.
Correct.
It's no secret that C++ is incredibly complex. In fact, this complexity has been the main point of criticism from many notable programmers, such as Linus Torvalds, the creator of Linux, Rob Pike, one of the creators of both.
Yeah, that is a problem. The tooling is worse. I mean, as I said, the IDE can help a lot here.
Tools that can automatically format your source code are super valuable. If you've used tools like Prettier, you might wonder if there's the equivalent in C or C++. So here we have a new profile in Visual Studio Code. The first thing you're going to want to do is install the C++ extension from Microsoft. From the command palette, you can type format, and there is the format document command, and that's going to make things generally a little bit prettier. It's going to put appropriate spaces for the comments, make your curly braces consistent, and spaces between different characters consistent. Most likely you're going to want to do this on save, so you can open your settings.json, and then add a value here to format on save and set this to true. Now, anytime I save my code, it'll automatically format. Now, there are different standards of formatting, so say you wanted your curly braces to look like this. Add this setting for the C++ extension, and here's an example value where you can configure the formatting and the indentation. There are various other formats available, so you'll have to do your research on what format you want to use.
So using your editor to format the code is fine. It's very good. And that's what most people do. Most people let the IDE or the editor format the code. But I mean, in terms of what we're doing with pipelines, we need like a command line tool to format the code, because people have their editor set to different things. And if we want to collaborate together and share code, then we need the pipeline to format it as well. So the editor is good locally, but on the server, we need to run a formatter on the code. So in C++, that's Clang Format.
And we want to make sure that everything looks the same across, dozens of different files. So what we could use instead is something like Clang Format. Now, to get Clang Format right on most Linux machines, you can do something like sudo apt-get install clang-format, right, to get that executable on your machine. And there's a number of different versions you can generally choose from, right? So you can just do this to get it on your local machine, and then you should be able to run just Clang Format, right? You may need to restart your terminal, right, in order to get the automatic completion of Clang Format. But, in its simplest form, we can just call Clang Format on a file like main.cpp. What it will do is it will format it and then print out the formatted output to stood out.
Great jumper.
Go ahead and do that. You can
Scandi
see that
sheet.
just running Clang Format, it gives us some nice pretty code here. So it fixed a lot of our poor stylistic choices in terms of formatting.
I mean, that does look better. That bracket being next to there, it's got space. It's made this into one line. It's made this into one line. I mean, this is a mess and it's made it nice. And yeah, this is a mess and it's fixed it.
For us, we didn't really have to do anything other than run our formatter. Now, there's a number of different kind of preset styles that you can pick from. So on the right-hand side...
I mean, one thing you got to, might be obvious, by default, Clang Format just spits it out. So in order to pipe it back into the file, you need to do -i. And then -i, and it will update the file. Otherwise, it will just spit it out, and then it'll look nice there, but then it won't actually affect your file. So -i to actually have it write directly into your file.
Side of the screen, I have the Clang LVM documentation here for Clang Format, and you can see there's a section on this style option. So you can also see this by just running Clang Format --help right on your local machine. So you can see that there are a number of preset options like LVM, GNU, Google, Chromium, Microsoft, Mozilla, WebKit, right, and so on and so forth.
I mean, this is where it all falls apart, really. In, say, Python, and it's true in JavaScript and Rust and lots of other languages too, that in Python you have black, which is faster. Rust version of it is called rough, but it basically just formats it the same, and you don't have to choose anything. You don't have to choose the preset style. Basically, everyone in the Python world is using the same tools, using the same format, using the same formatting style, and that really helps a lot with readability with Clang format, because everyone's using a different format. You lose a lot of the advantage of it. You get the local advantage of locally having the code in the same format, but you lose the kind of global that everybody who uses Python has the same format. You don't have that in C++. The rot immediately starts here. The rot continues much deeper because those other tools like black and rough and Rust format and all those things, they are a set of rules that are universally applied to the code. Clang format is way too clever. It's doing some heuristics. It's not simple, whereas tools like black and rough and Rust format and prettier in JavaScript, they are deterministic. They'll always do the same thing. Clang format is technically deterministic, but not in an obvious, clear and obvious way to the user. It's basing on a series of rules and priorities, and it's judging things and it's juggling things, and it's just too clever. It's just too clever. It's too intelligent. We don't want it to do any of that. I'd much rather it was like black or like rough format, or like rough or Rust format.
So here what we can do is we can run Clang format again, except this time we'll choose a different style here. So maybe instead we'll choose a style equal to, GNU. Right, you can see we get a slightly different result here. So now our main function looks a bit different. It has a return type followed by the name and parameter list here, right, in these parens. Our curly brackets, right, are on a different line than say our function here, and that's also true for say our for loop down here. So slightly different stylistic choices. So you'll find that these different styles or preset styles, they can look slightly differently depending on your code, right? So we can try something else as well. So we can try styles equal to something like WebKit, and again we get a slightly different style, right? These really all just personal preferences by these different organizations, right? I think in general, if you have control over choosing the style, pick whichever one looks right for you and works best for you. A lot of times in industry, a company will just choose some style. They might tweak it a bit, and then they'll just have that set style forever.
See, I mean, this what works for you thing kind of removes the whole point of the formatter. It does reduce a little bit of churn in your Git history, but the good thing about Python is that all the code always looks the same because everyone is using the same formatter, like according to the same standard, the same style. It always looks the same. Whereas in C++, it comes with 1, 2, 3, 4, 5, 6, 7 presets, and then everybody has their own local version. Every software project has their own different tweaks to it and changes to it. So you just don't have that standardization. There's like 100 styles really, or a million styles. Like every project has its own style. It doesn't get you really the advantage of the kind of defeats the whole point of the tool. It frustrates the point of the tool, which is that the code should be the same, so it's easy to read.
What we can do with the style is that we can actually dump out all of the options for these styles to a file called this .clang format file. So what we can do is,
I mean, obviously with Python, it's an easy gig in the sense that the indentation is significant to the language, so there is only one right way to do it a lot of the time. So like a lot of the things they argue about in C++, like where to put this bracket, for example, is in Python you don't have a choice. You have to do colon and then indent 4, and a lot of that is standardized, but it just means that it's easier to read. It's much easier to read Python code because it always looks the same. So that's, you write the code once and then you read it loads of times. So you need to optimize for readability, not for ease of writing.
Take something like, we'll remove this main.cpp from here. We'll select a style like Google, and then we'll do --dump -config here. And it'll actually dump all of the config options that we have, right? So you can see this is really where all of these formatting choices are made, right? So we have things like these include categories, so how we're going to sort our include statements.
So, I mean, it's typical in the C++ world is that you never really get to code anything. You spend all your time trying to fix your make files or configure these things, and it does distract you from actually getting on and getting the code written.
We have, things about, continuation indent with.
And they're kind of fun distractions. It's fun to configure stuff. It's like power.
And different arguments or options related to spaces and line breaks, all of these different align options and so on and so forth. So there's a huge amount of customizability when it comes to these formatters, right? But in a lot of times, right, we'll just use some default style or we'll do a minor edit, right, of these style files. So what we can do with these style files is we can dump it. So I'll just redirect this output to a .clang-format file, right? So now when I go ahead
And this is the key point. Everybody has this Clang format file. Now I've told you that. Well, if you look at the source code of any big C++ projects, you'll see they all have these .clang format files, at least one in the top directory and maybe others. So you might have a open source project where there's an overall style and then like different modules in that application have their own substyles. Okay, that's a very good video from Nick. You can watch the rest of that.
Clang Format is a tool for, obviously, formatting C and C++, and it's not present in the kernel documentation you'll find actually, but it's good enough. But is it really a standard tool for formatting? We at JetBrains has a tool that can scan the GitHub based on some conditions and filters, and we actually did that. And I found out that in the repositories with the primary language of C and C++, only 8.65% of them has Clang format file at any level inside.
This is really interesting. So C or C++ with 10 plus stars, there was 163,420 repositories, and only 8.65 of them had a .clang format file. So this is like really different to the JavaScript world where everyone will have Prettier, or in the Python world where everyone will have rough or black or something that implements the PEP8 style. In C++, there doesn't seem to be any other tools but Clang format, and nobody's using it.
It's truly a standard tool when we only have like 8% something of the repositories with the config inside. I don't think so.
With C, your compiler is your user, right? You're writing for the compiler. And if the compiler compiles it, then in some sense, you care less than you do in Python or in JavaScript. There's something about the community. It's like the compiler is the god, so you write for the compiler. It's slightly different where in Python, yes, the interpreter is the master of it, but you don't. It's not quite the same extent of like, if it compiles, ship it.
Also, actually, Clang format is known for breaking the compatibility, right? You know that, especially when they take the parameter, which is like Boolean, and then convert it to the enumeration, and everything is just broken, so the company just sticks to one specific.
And maybe, I said, the reason that Clang tool isn't as popular is just because it doesn't do what it needs to do, which is force one style on everyone and apply that style every time to the same, when your code has a function, every function looks the same. Whereas in Clang, that's what it should do. But the Clang format is like, well, there's heuristics. I'll balance what it should look like against line length. We'll balance it against this and that. And it doesn't produce the same output. You have two functions and it'll format them completely differently because the other heuristics are... Like, I remember when their Icelandic volcano went off and I was in a desperate rush to cross Europe by land. If you go anywhere to McDonald's, you'd get a predictable thing. You can get a hamburger and chips. You don't have to like mess about if you're in a rush with McDonald's. In Python, you have that McDonald's feeling to it. Like, you'll always get the same thing. It will always work as you expect. It's predictable. May not be the best, but it's predictable. Whereas C++ is more like home cooking. I mean, it's like when you go... If you go to holiday somewhere and... you've got nothing really to do, then camping is fine because the process of camping takes up all the time. Like the process of building your shelter, building the fire, cooking something. It takes the whole day just to do the practicalities of life. Whereas if you're going to a city and you want to go to like a tech conference, then you just want like a good hotel that will just provide everything for you and you don't have to think about anything. The reason that like Python and JavaScript ultimately won was because shipping is more important. It's more important. You've got a market need for something, a business need for something, just ship it, get it out, rather than, doing the Michelangelo's David chipping away. Obviously, there are cases where you care about performance and you care about, you've already solved the problem, and then you start digging into the C++ side of things. But yeah, back in the day, before we had Python, before we had JavaScript, before we had really fast servers and really fast clients, you really needed that performance to get the community to do anything. So, C++ was vital in the 2002 era still. In the 2002 era still, you couldn't like let a Python script munge away for like 10 minutes, whereas now the servers will do it instantly.
Version of the Clang format on their CI and never upgraded. Okay, so it's about the formatting. What about the guidelines enforcing tool? Is it really one of many other Clang-based tools enforcing the guidelines on us? Let's start from the end. A question there where we are.
So basically finds out there isn't really anything else. There isn't really much else than Clang format. You've got the IDE enforcing the thing, which is good, but it's basically there's not much else apart from Clang Analyzer. And Clang Tidy, which is slightly different. Clang Tidy, we'll get to that, but that's more like the PyLint, whereas Clang Format is more like your Black or your Pep8. You know, Clang Tidy is more going deeper into potential issues, whereas Clang Format is your fast formatter. And in terms of the server side, that's basically it. I mean, this guy dreams of code.
So C++ is pretty great, and you may think it's worthwhile learning. But before jumping into a C++ tutorial, it's worth understanding some of the drawbacks to the language. The tooling around C++ is nowhere near as wonderful as it is in other languages.
So it's not me saying this alone. It's saying the streams of code saying, and then Prime claps it. We have this article here. Clang Format considered harmful. I don't know of a good C++ code formatter, because basically you've got Clang Format when you go home. But Clang Format is not one. It's a thing I don't like about C++. So this guy is comparing it to Pythonic rustic formatting. So like comparing it to Python and Rust. Somebody else says, I think Black and Go format beat any of the options I might have of me. So this person, like this other person, has used Black and Go format, and it says formats like Black and Go format offer me zero decisions to make, so I just get down to coding and learn to love the formatter. Clang Format offers me several choices, so I spend a bunch of time making possibly incorrect decisions about things that are ultimately inconsequential. There is definitely something in it. Like, he then replies himself and says, to be fair, there isn't really like a cohesive C community. I mean, there's a slight problem with the Python community as well, is that when Python was like a minority thing, we had a really tight community, and now it's like taking over the world. Nobody really talks about Python anymore. Everyone talks about machine learning or web application development. It's all very specialized, and like the bigger side doesn't talk to it. It's the same thing with Linux. When Linux was like a new alternative, revolutionary, radical thing to use, the Linux community was really tight, and now that Linux is everywhere, you don't have the same cohesive community, because now there's like very specialized things. There's a problem with success, is that you kind of lose the friends. You lose your friends when you get successful, right? There's kind of like a problem with that. But anyway, C is because it's so big. It was so big for so long that it just doesn't have the same like one. As I was saying, like, there's not one C. There's not one way to write C, because as soon as you start writing C, you hold on to some ecosystem. So if you're in the Linux ecosystem, you'll have glib and all that kind of stuff. So you'll soon start having those kind of like the GNU tools and the GNU standard library, and you'd have all those things. Whereas if you're in the Microsoft world, you'd have all these other things. And if you're in the Apple world, you'd have Objective-C and all these other things. So it's not quite the same as, it was never like cross-platform to start with. It gained cross-platform approach later. I mean, this is an interesting example in here as well. Valiant says, it's a little bit too simplistic. It doesn't allow you to express what you want to express. Say you're doing stuff with buffers, and the function takes the buffer and the buffer size. A common pattern in the C world, because you don't necessarily know the size of something. It's quite expensive to work out the size of something. In Python, you probably wouldn't see this as much, because you have a len function, and then that'll cache the length of things inside the object. Getting the length of something might be quite cheap when you're doing a more manual memory management. You've just got a pointer, and you have to like go around to find out how something long is, or maybe you don't want to process it in advance. But you know how long it is, and you don't want to have to like keep going through the data to find the length. It's quite common to have this kind of pattern where you know the length and you tell the length to the thing that's going to go and use it. So this is a very common pattern here, and this is a very beautifully written function call, because you can just immediately go back and read it and read that matches that. So say this buffer was called transactions or something, and then 50, you could see like immediately what the size was, and whereas Clang Format will squish it into this where it's not so obvious anymore. So that's an interesting example. I mean, I don't want to be trying not to be overcritical. If you haven't done multiple languages, it's very easy to be defensive. So if you're just a C++ programmer and you are comparing just being in the Wild West with no formatter, and then you adopt Clang Formatter, you might think it's the best thing since sliced bread, because you're just comparing it to nothing. You're just comparing it to like, stones. But if you have used Black or Rough or Go Format or whatever, or Rust Format, I'm sorry, it's a Clang Format just isn't as good. Maybe later I'll change my mind, but I just find this whole heuristic thing, you'll see, this whole heuristic thing where it doesn't do the same thing every time, that just, yeah. That kills the whole point. And the second thing is that not everyone's using the same format, so that kills the whole point as well. So there's like, it is working against itself. Too complicated. Sometimes simple is just better than complex. But as we found out, there is no alternative. What'd be great if somebody took rough or black and made a C formatter based on that. But basically, you've got this, and you've got the things in the same ecosystem. So the Clang Tidy, Clang Analyzer, these are the same things with these are the same set of tools. And most people are just using the tool used by the IDE, or they're just using nothing. 91% of people are just using nothing rather than having to use Clang Format. So back to the article. First, I must dispel 4 off-cited myths used to argue for uncritically slapping on a random coding standard. Myth 1. Any coding standard is good as another. There is such a thing as practicality in coding standards. Before even contemplating controversial topics like aesthetics, it's not hard to think of aspects of code forming that contribute to right application. How big a change becomes in a resulting diff. That should be uncontroversial. Let's get the basics right. This is very interesting because he's actually saying that, one way to format a function is more practical than other ways. So a good way to format a function, you should be able to add or remove an element at the end, and kind of ironic worst things that the format can come out with. So after inserting something, you want these to fix. Dependent indentation. So this thing, you might have a really long name and you replaced it and then you forgot to reformat. So it turns out looking really weird. Indentation dependence. When changing the scope of a section of code causes the formatter to change strategy. Human predictability. Does the format follow rules that a human with infinite experience can predict? Or does it play chess with the sum of weighted costs? In practical terms, must you run a format locally in order to write anything that CI will accept? There exists a format that has none of these problems. I'm of course talking about the self-evident Python rustic formatting, which probably has many more names, where you do XY. I think this is probably called the KNR format. I don't know. So he's saying this is the good format. I think this is what people want. Myth 2. The most important thing is to have a coding standard enforcer. He's using this to say some formats are more practical than others to reduce the churn of code. I mean, that's really what you want, especially if you're in a large group. Say you've got 20 people coding on one repo every day, especially like corporate environment. You might have 20, 30 people committing to the same repo. Churn is terrible. You don't want any churn, and you especially don't want churn because your format is a bit crazy. So he's saying this format is better to reduce churn. I remember a time before Clang Format. I would say professional developers did at least as good of a job of Clang Format to begin with. In fact, some ways better than any autocorrector could have ever come up with, because the human knows best, such as which arguments associated, like the buffer example where we had lengths. Myth 3, it's possible to configure Clang Format to a Pythonic rustic style. This is the problem. I have tried every option. There is alignment after open bracket, but you have to do the rest yourself in terms of remembering trailing comma, which is only applicable in curly braces and not enforceable. Forcing line breaks with line comments and liberal use of comment Clang Format off. So if you have to turn off the formatter to have the format you want, that's not ideal. Because he basically wants this, and Clang Format isn't delivering it. Properties of a good formatter. Sensible by default, or a sensible configuration after the criteria above must exist in this configuration space. Slack. Human knows certain things better than the formatter, such as which arguments are associated, and may therefore have a preference for where to break the line if necessary. The formatter's job is to not take this freedom of expression away. Its job is to satisfy a disjoint set of requirements. Therefore, it must allow more than one way to lay out the same code. Python formatters do a good job in this department. They need to be humanly predictable. So what's wrong with Clang Format in particular? All the above. If Clang Format behaved like a Python formatter or like Rust format, you wouldn't be reading this. Although no fan of automatic formatting in general, other languages have it better. Another person says, some real issues I have with Clang Format. Different versions of Clang Format with the same config will produce conflicting output. Thus, if you run both versions on the same code back to back, they could flip-flop between output. In many other auto formats, the newer version is solely a superset upon the previous versions. Getting everyone running the same version is non-trivial. This is largely the problem with C++ and its overall tooling story, not Clang Format itself, but especially compared to built-in linters like Go Format and Rust Format, or self-contained virtualized toolchains on projects such as JS Node or Python ecosystems via Docker VM. It's a pain. The C development world is very dependent on the operating system, so if different people have different operating systems, they can end up with different versions of it. So if people are saying it's slow on Windows, and people saying it's fast on Linux. But that's in general. It's a general thing, isn't it? The main reason myself included like machine dictated formatting to reduce eliminate time wasted on bike shedding. I want to like formats, but at the end of the day I find that human logic is really the best. Formats tend to focus on unimportant things like line length. What I care about is line complexity. I want to keep each line having one, maybe two ideas. No format can understand that. I don't mind some basic formatting such as brace style and fixing indentation, but after much more than that, I find it's putting things onto one line when it shouldn't, or vice versa. Things like Clang Format have tried to take on too much and really make all your code look the same. But I've never been confused by code because you used A plus B rather than A plus B. Somebody else says, I love code formatters, but this problem is my pet peeve. When I choose a coding standard for a new project, my top priority is choosing a flavour that avoids write amplification. A standardised format is great, but not if it can interfere with code review. I've encountered too many bugs hiding inside a diff hunk that was 90% auto-formatting noise. I've had no luck with diffs that hide whitespace change. And then discuss the problem with diffs. Yeah, most code reviews are diffs, and then if you don't review diffs, you review the finished file, then you might end up reading a lot of code, which is one reason to have short files, but also even that doesn't solve you because you can't see what the graded interaction is. So there is a bit of an art to code reviews. A code change might look really good, but then if you don't see the code around it, you might not notice it doesn't match. A typical PR changes 100 lines of code in 3 to 4 files, each of which is thousands of lines long. Telling people they should review the entire file when reviewing the PR rather than changes is the same as telling them they should not bother doing code review. You're advocating for something that's completely infeasible. Yeah, and then somebody says, don't let your files become 10,000s of lines long in the first place. Yeah, I mean, if you keep your code files down to 200 lines, they're quite... I wouldn't include imports or includes as part of the total, but if you like a Python file sometimes can be half imports. And the more you split it up, the more imports you get. So it's hard to win that way. But yeah, even if you have a file that does one thing well, you still can't necessarily see how it fits into the bigger system using your head. Eventually, at some point, you have to be a human engineer. Myth 3. It's possible to configure Clang format to Pythonic rustic style. By that, he means he wants that bracket there, and then he wants one argument to a line. Clang format can't stick to that. It just does all kind of different things. It puts in all kinds of different formats. No comment, as I've got no idea what you're talking about. So this is the problem about stones, right? So if you're comparing Clang format to stones or to nothing, then of course it's good. But if you're comparing it to other things, and if you don't know there's other things, then you wouldn't know that the grass is greener on the other side. So Plato's cave's problem. Somebody says, believe me, I've tried. If somebody could point me the equivalent setting for what Rust format calls indent style, that would be my hero. Yeah, this is the style that he wants, that everyone wants. And this is a style that Clang format wants to do, I guess. This is the style that Clang format wants to do, where it puts these huge white spaces here. But if you rename this variable, then these all got to shift. Whereas if you rename these variable, these don't have to shift. So I'm with the original poster that this version is better than this. This format is less prone to write churn than this. They call it write amplification. I just call it churn. The more churn, irrelevant churn in the PR, the worse. Your PR wants to be surgical, showing what the difference is. You don't want to see a load of formatting churn. There we go. So that was what we don't like about Clang format. And then need to go on to talk about how Clang format is great. But I think it was getting pretty long already. So then we're going to stop here and pick that up next time. Sounds a bit of a downer, but I could see C++ fans saying, oh, this long-haired, woke Python script kiddie has come over here and is saying, with this Napoleonic communist attitude, that everyone has to write the code the same and everything has to look the same, and where's the freedom? The C++ people are a more libertarian bunch, essentially, than us Pythonic dictators, right? So that is a true cultural difference. I mean, we've chosen to have a high-level approach because we want it to be very fixed. We want it to be very, very standard. We want a virtual machine running it to limit the amount of things that the code can do. And for that, we're willing to sacrifice manual memory management, a bit of performance, so on and so forth. So it is very much a cultural personality thing that the Python community is much more up for dictatorship, communism type approach, whereas the C++ is more libertarian in its culture. But anyway, Clang format is great, but I'm going to talk about it more a bit more practically in the next video. But anyway, well done for getting this far. You go code something.
Back to her and I'll go back to. We only said goodbye with words about 100 times. You go back to her and I go back to.